So this is the fourth question of CodeChef Starter 119 Division 4. Another good string. In this question, basically a string is defined as beautiful if all the characters in it are same. So this is a beautiful string, even this is a beautiful string, even this is a beautiful string. But these strings are not beautiful, okay? Because they have different characters. Now you're given a string and you're given some updates as well. Basically, like they give you the length of the string and they give you the number of updates value in the input format. So there is the length of the string is 6 and the updates are 4. Okay? And this is the string given to us, which has a length of 6. And these are the 4 updates. Okay. So what we do in every update is we basically append this character in the update to our original string. Okay. And we keep doing those updates 4 times. Basically, the number of times the updates are mentioned, right? And what we need to find out is, first we need to find out what is the longest beautiful substring present inside the original string. So a substring is just any contiguous segment of it. So in this case, the longest beautiful substring will have a size of 3, okay, which is this, basically n and n. Now we need to find what's the longest beautiful size of the substring initially, and for all these updates, for each update, we need to again find out what is the longest consecutive beautiful substring in the updated string, right? Okay. And the constraints in the question are the test cases can be up to 2 into 10 power 5, n value can be up to 10 power 5, q value can be up to 10 power 5, and every character in the string is basically a lowercase English letter, and the sum of n and the sum of q over all test cases both never exceed 10 power 5. So this is one important constraint as well. Basically, this constraint ensures that even if you sum of n and q values out of all the test cases, that will never exceed 10 power 5. Okay. So essentially, it would be similar to a one test case having n value as 10 power 5 and no q value. Okay, something like that. Right. Okay. Anyways, we'll discuss that when we discuss about the solution as well. So yeah, let's understand how we solve this with the help of a test case. Okay. Now here the size of the string is 6. We have four updates, and these are basically the update values, right? And this is the string given to us. Okay. Now, firstly, we find the longest beautiful substring inside our original string. Okay. The way we do that is we just simply run a loop. Okay. We run a loop for, let's say, I in the range 1 to n minus 1. Okay. Now this is inclusive. So okay, this is 1 here, right? Yeah. So this is inclusive. Basically, the loop starts from 0 and goes till n minus 1. So it covers all the indices. And what we do in this case is we basically check if s of I, whether it's equal to s of I plus 1. Okay. If this condition is true, we basically also maintain a counter. Okay. Let's call it a counter. We'll initialize the counter with 1 because having a count as having a longest beautiful substring as 1 is always possible, right? We can basically just pick up any character, and since the condition is that all the characters in that should be same, one character will satisfy that condition, right? So count can always be 1, right? And we'll also say that the answer is also 1 initially. Okay. We'll update it eventually, of course, but initially we can say that the answer is okay. So this is basically the pseudocode starting from here, right? So we check if s of I equals to s of I plus 1. If this condition is true, we basically can say 10 plus plus, okay? Right. And in the else condition is where s of I is not equal to s of I plus 1. So in that case, basically there is some point where it has broken. So initially let's say we compare these both ends and s of and count. Okay, I mentioned temp here, right? It's not temp actually, it's count. Okay, right. So initially count was 1. So when these comparisons became true, count value incremented. When these became 2, it incremented again. Basically, it became 3. And when it came to this part, this condition failed. So basically, it could not be incremented to 4 in that case. So that's where we stop and we say that 3 is the length of the longest substring we obtained so far. Okay. Or we can say 3 is the length of the longest substring we found at this point. Okay. Right. So in that case, we'll just say answer equals to maximum of answer and our count. Okay. And we can reinitialize the count to 1. Okay. Basically setting it back to 1 because we found one substring. So let's just keep it open for other possibilities in the future, right? Okay. And we set the count back to 1 and that's it. Okay. Also, we do one more operation at the end because what if there is the longest common subsequence is present at the end and the count kept increasing, but it never went to the else condition, right? So that is one more possibility, right? So in the last, we put another statement like answer equals to max of answer, comma, count. Okay. And then we'll basically print the answer. Okay. Now this will basically be the value of the longest beautiful substring in the original string, right? Now we also need to ensure for the updates, right? So for each update, so let's just say for each u in the updates, okay, u basically represents a character, okay. So for each update in updates, okay, what we do is first thing we say s equals to s plus u. Basically, we are appending that character to s. And now what do we do is we say if s of size minus 1 equals to s of size minus 2. Okay. Now size basically represents the size of string s. Okay. So you can use the functions in your respective languages and replace it. Okay. So s of size minus 1 basically indicating the last character which we just appended and the character before that. So the last character before the appending took place, basically if they both are equal, our count will keep continuing. Okay. So count may have some value. It might be 1, it might not, it might be more than 1. So the count value retained from the previous for loop will be continued here. Okay. So in this case, you do count plus plus here. Okay. And in the else case, what do we do? The same thing. We'll say answer equals to max of answer, comma, count. Okay. And we'll say count equals to 1. Okay. Right. Now, here we do one more additional thing. Since we want to print the maximum length of the substring, maximum length of the longest beautiful substring at every single point, we also do this operation. Now here we did it at the end because we just wanted to know the answer at the end, but here we want to know it at every single point, right? So here we do that operation every single point. So we say answer equals to max of answer, comma, count. Okay. And we basically print. Okay. Right. So yeah, that's it. That's how we solve the question. For every update, you update it, check, compare the last and the last second. If they are same, then just update the count. If they are not same, then update the answer and reinitialize the count to 1. Okay. So yeah, that's how you solve the question. Just some basic implementation is enough to solve this question. And since we just run a for loop for queue updates and for the n-length string, the time complexity in this case will be O of n plus q. Okay. And since we are updating every single time, our space complexity will be not just n, but n plus q, right? So for each update q, we are appending it to the string. So some additional space is also required there. So this is the time complexity and space complexity. And given the constraints that n and q are in the range 10 power 5 from 1 to 10 power 5, this will satisfy our criteria and it will not give a TLE, it will work. So yeah, that's how you solve this question.